Now being recorded.
Hello, everyone, and thank you very much for joining us for today's Community Informatics teleconference. My name is Jonathan Pollack, and I am the CUAHSI User Support Specialist. Today we have two items on the agenda. The first will be a demo of the Open Hydrospheric Modeling Framework by Yao Liang and Yao Liang. Sue is from Pitt, and Yao is from IUPUI. And I'm just going to read a brief introduction from their EarthCube Concept Award page. OHMF is an open meta-modeling framework which can integrate data and models easily and incrementally for knowledge discovery and management for the research and applications communities with the initial focus on the hydrosphere. So today we'll have a brief demo or a PowerPoint as well as a brief demo of the system, and then after that we'll also hear from Alva Couch, who's the director of the CUAHSI Water Data Center, and Alva will be talking about exposing CUAHSI variables as a SKOS service. So with that, Yao, I'd like to hand it over to you, and thank you again for joining us today. We're all looking forward to hearing more about the OHMF.
Thank you very much, John. My name is Yao Liang, and we present on behalf of our concept group. Su Liang is the PI of this eager project. Daniel and Miguel are two PhD students who are working on the development of this prototype system. First, let me briefly introduce our project goal for this work. So we want to develop an open data, open modeling framework to integrate the data and the models easily and incrementally for the geoscience community. And this framework will allow people to freely contribute their individual models, so connect their model to this framework, and so the model can interact with each other. At the same time, any model connected to this framework can access different data sources that we have connected to this framework. So here are some features of our framework. We promote the open data, open model, and we provide data fusion and simulation mechanism in this framework so that data from the different sources and from model outputs can be very easily fused based on your need. This framework provides you the flexibility because you can very easily to connect your model into this framework to access all the other data sources. You don't need to develop the interface with other data sources, by yourself, and to easily interact with other model already connected to this framework. And it's very easy to use, and that's our goal. And so through the web. And here is the big picture of our system. So our system is the part of this the orange dotted line. So that box is our system. Is the major part of the system. So we have the system core and the data agents as well as the model agents. I will talk about more about the data and the model agents later. And the system core interact with the workflow engine. So the workflow is used in this framework to organize your task. This is the high-level architecture of our framework. So as you can see, the core part is the system core, which is overall control mechanism, and the data model, and the data representation, data storage, the database for this framework, and it through the model agents and the data agents to connect to different models and to connect to different data sources. The system core connected to the workflow engine so that the whole work can be organized, can be controlled by the workflow. And the website allows you to configure your applications through the web, and you use this framework from the remote site. So that's the basic architecture. As you can see, based on this architecture, once every data source, we only need to develop one data agent to connect it into this framework. Once this data source is connected into this framework, any model connected to this framework can freely access that data source. And so any model connected to any model also only need to develop the one model agent in order to connect to the framework. And once it is connected to the framework, it can interact, it can couple with any other model connected to this framework. So that's very convenient, very flexible. And this is what you can use this framework in your working environment. So basically, you are a user which is remotely, can be remotely from this framework. You can configure your application remotely, and all the models can also be run remotely or locally with this framework. All the data sources, of course, they are remotely. And next, I will very briefly introduce our data agents in this framework to show you how they work. And so we consider the most widely used data access protocols, such as the OpenDAP used in the NASA data center, and the web services used in the HIS, CUAHSI HIS, and the USGS and the FTP, and so on. So we consider those popular used data protocols. For example, here is the data access services that we can get from the NASA, the Goddard data center. So they provide the different mechanism, OpenDAP, GDS, FTP mechanisms. And this is illustration of the NASA data, what kind of data they have, we can access through our data agent. And here gives you example, the USGS water service data, and so that's what the web service they use to access the USGS data. So you can configure your query, web service query here, for example. And this is to show as you know, the CUAHSI HIS system, which has 3 components, and the HIS Central is for the data discovery, data search. So it provides, actually in the HIS, it provides 2 types of web services. One is for data search, data discovery. The other one is for data access. So here is the example for the CUAHSI data search. So now we can do all of them, access all of them by implement the data agent to each data source. So this slide shows you what the current data agents in our framework. So at the right-hand side, you can see you have the USGS data server, you have the NASA Gardner data server, and you have the HIS data server and the data central HIS central server for data search. So for each server, for each data source, we develop an agent. So for example, for the USGS data source, we develop USGS data access agent. For the NASA, we develop the OpenDAP agent because we use the OpenDAP protocol and to access the NASA data there. And for HIS Central, we have two agents. One is for the data search, which just like the hydro desk that you can use the HIS Central to search data, and the other one is to use the Water One Flow server to actually access the data after you search it, after you found it. So you have two agents there for the HIS system. So and in the future, when more we can easily add the more data agents into our framework to connect more data sources. For example, for just to add the data agents for HIS system, CUAHSI HIS system, we use just about 1 month. So now we implement the hydro desk functionality in our framework. So our framework includes the one workflow engine. In principle, any type of workflow engine can be connected to our framework. And in this prototype, we picked up the waste trails. Waste trails because it has a lot of good features for our needs. So we listed this is an open source workflow engine, and it has a lot of good features for us to use, and including the good data visualization functionalities. So we use the workflow, waste trails workflow in our framework. And this is just a brief example, the screenshot, and Daniel later on will give you more detailed demo. So this shows you that when you use our framework, you access two data sources and fuse them together. As you can see, the one box fuse two data sources together. And then the show data set basically to display the original data as well as the fused data. So this is the result from our framework to show you the access data. Those data are accessed from the NASA data center. Okay, so that would be the basic introduction of this framework, and this work is supported by the EarthCube Eager grant to our concept group. And thank you very much. And let me say if you have any questions.
So unless anyone has any questions now, I think we could probably move on.
Here. I have a quick question, John. Yao, you talk about an HIS agent as opposed to a water one flow agent. I assume that means you're hitting the HIS catalog for discovery purposes. That's the HIS agent as opposed to hitting a water one flow agent, which is to get the data directly. Is that the distinction you're making?
Yes, that's correct.
Okay.
So that's correct. The HIS agent is the agent for the data discovery, web servers.
Okay.
The water one flow agent is the agent for the data access. That's
okay.
correct.
Very good. Okay, thanks.
So this is David Talbot, and I've got a question if you've got time.
Yes.
So I guess, how do you actually implement a model? What do you have to do to a model to put it in this framework?
You mean the hydrological model, or what kind of a model?
Say you showed an example, or you showed a slide that had VIC, DHSVM, a few other models. Say I had my own model, what would I have to do to it to make it part?
Yes. The way to integrate your model into this framework is to develop a corresponding model agent. And like you can see in this slide, so every model, if you want to connect to this framework, you are going to develop this model agent. Basically, our framework provides you the facility how to develop this model agent. So when you develop, so that way the development of the model agent is not very difficult. Actually, as I mentioned, when we develop the HIS agents, those data search agent and the water one flow data access agent, we use just 1 month.
I guess I worry a little bit about the saying it's not difficult and 1 month. Do you have specifications for what, I guess, how one would develop a model agent, or what it needs to do? And I guess I'm thinking in the back of my mind when I'm asking that, how this compares to other systems such as perhaps OpenMI that also provide degrees of model interoperability, and I guess CSDMS also has a system for model interoperability. So would I have to write an agent for this, a CSDMS coupler, an OpenMI coupler? I guess I wouldn't know where, or how do I choose what framework I want to use for my model?
Okay, so let me explain the differences between this framework and the CSDMS framework. In the CSDMS framework, you definitely can do the model coupling and component-based model coupling. However, you need to know more details about the models. So, for example, if you want to couple your model with a VIC model, then you have to understand very detail about the VIC model and each component inside the VIC model, and you need to know a lot of computer stuff, a lot of numerical or algorithm numerical stuff in order to make that coupling right. Otherwise, it may not work. So, in other words, in the CSMDS coupling framework, it supports the more tightly coupling so that you can have better performance. But in our framework, we support the loose coupling. When your model connects to this framework, the interface that you need to develop with this framework is at the data flux level. It's not at the variable level. In the CSMAS, you can do the coupling at the variable level. So that will be in very detail. But here it's at the at the high level, at the data flux level. So basically, you say what at this level, you can interact with other model also at the data flux level.
So
that way.
When you say data flux, how is that different from variable?
Data flux is as a data flow. The variable is at the as a state variable. That will be at a much detailed level.
So
that will be at a much detailed level. The data flow level is at the much higher level.
So let me try to jump in, because Dave, what I think, this is Rick. Dave, what I really think the value of this is I see it, and Yao and Sue might disagree, but to me, I would see the user here saying, I have a model. I'm not trying to connect it to another model. I'm not necessarily trying to make a library of models. I have a model. I want to get it into OHMF primarily to take advantage of the data agents and visualization agents that are there. That's the use case which I guess when I've seen this demo, which we probably need to get to, but that's what strikes me. I think this is to my mind, the whole crux of this issue, if this is going to be a useful tool, will be how hard it is to write that agent. Just what you said, Dave.
Okay, right. So, I mean, I can certainly see there's a tremendous value that one way of thinking of it is you've got this system as the system core kind of at the middle, and the way the models interoperate is model 1 takes its input data out of the system, runs itself, then puts its results back. Then model 2 takes perhaps the results from model 1, runs and then puts its results back. So the workflow is effectively a chaining of models with the common data system serving as the mechanism for data exchange. And I think that's quite a powerful concept, and that also connects it to different data sources. So,
to me, what I found interesting here, and you'll see this when I did the demo, is the fact that by putting my model in this system, I have access to these data agents, which will go and use the NASA services to subset a NetCDF file for me on the fly. I don't have to do that myself. It comes in and it's available in NetCDF format, ready for my model, if my model understands NetCDF. And similarly, I could access the water one-flow services. That's what I saw is really the power of this system. And of all these sort of generic workflow environments that we've looked at over the years, for the first time, when I'm looking at OHMF, it seems like this is solving a problem people have, and hence there's an incentive for people to start and learn how to use the system, so long as that barrier of writing that model agent can be made sufficiently low. And I think that's
right, so that's going to be the crux, I guess. Yeah.
Yeah.
So sorry, I don't want to hog the discussion, so we can move on.
Sorry. Rick and everybody, hi, this is Sue from Pittsburgh. And in addition to what Rick pointed out, on the other aspect of this framework, it's also it facilitates the model intercomparisons very easily, in a sense that, for example, we have different hydrological models. If we have them connected to the system, for example, and if I'm an atmospheric scientist and I want to do some other studies, I don't need to understand the details of hydrological models, and I don't know, for example, how different hydrological models perform and which one is better to meet my needs, and I don't have my students to have the background to understand all that details. However, I do want to use them, and then this platform would provide a tool for them. For example, they can get onto this platform and use all the data, like Rick pointed out, that are connected to the system, and check it out and run all the models and compare the results and do the analysis of the results. Instead of explore individual models by themselves and connect the individual models to different data sets and then run the models themselves and do all the interfaces of different models with different data sources. That's another aspect of this framework in terms of the open model, from the open model perspective. So I just want to add a little bit onto that, and we can have Daniel to do the demo, and after the demo, and we can answer more questions.
This is Scott Peckham. Could I ask a quick question before we move to the demo?
Sure.
Can you hear me?
Go ahead real quick. And
sure.
Why don't you relinquish the screen control so Daniel can get control of it?
Okay, so my question is similar to Dave Tarbotton's. I'm part of the CSDMS project, and the way it was described about how models go into our system and needing to have deep understanding of each model, that's not really correct. We've also tried to design a system where there's a very low level of entry, where you have to meet this BMI interface, which is basically just describing your model in a standard way to the system. And for some people, it's a half a day's work. Sometimes for people, it's more work. But it's a low-level framework-independent target that describes your model and lets the model go into the system. Now, that seems kind of similar to what your idea of an agent is. I mean, anytime you have to write some work or do a little bit of work to describe your model somehow to the framework, you're really doing something very similar. So I don't understand the distinction that you were making between this and CSDMS. Could you elaborate on that?
Yeah. For example, I look at your website and I talk to people, and this is how the impression I got, but it could be totally wrong, of course, without actually getting my hands on it. And so by looking at the website and talking to people, the impression was that people give you their models, and then the models, like you said, the description of that, but then in order to have the model to be into the components and into the system to be operatable, and then there would be a person from CSDMS to get those codes down for the modelers, and so that they can be in the system. And so, and sometimes that person, the computer person from CSDMS, needs to take a little bit longer time, and sometimes it takes a little bit less time. But then the impression was that it takes time and to get the model into it, and that is very that is true, that because the model, one of the strengths to me is that the CSDMS can be coupled at different resolutions in terms of the models, and they can be coupled at very fine resolution, which is what Yao mentioned, at the variable levels, and they can be coupled at a higher resolution, which is modulars, and they can be coupled at even higher levels, and so they can be coupled at multiple resolutions. But on the other hand, if they want to couple it at a very fine resolution, at the variable resolution, they really need to consider the algorithms and understand the models themselves when people connect them, because otherwise, for example, the stability could be a problem, and also other things related to the algorithms of the compatibility and the consistency among the different modules. And so those are possible, and from my understanding, and of course I could be wrong.
Scott, here is my thought about your question. If you just look at one interface to connect the model, one interface, that could be similar. However, my understanding is that in CSDMS, if I have 5 models to interconnect with 5 different data sources, you have to develop peer-wise interfaces for that. So how many total interfaces you have to develop? You have to develop 5 times 5, that's 25 different interfaces, because all your interface is peer-wise. Here, if we have the same situation, 5 models and 5 data sources, we want to interconnect all of them. How many interfaces we need to develop? We need to develop 5 model agents and 5 data agents. So totally we need to develop 10 agents rather than instead of 25 interfaces. So I think the coupling is at the different level. In your case, is at a peer-wise level, which has the advantage to be more performance. The performance is better sometimes because at the peer-wise level, it allows you to do very tight coupling, because that coupling is only about those two entities. So you can do very tight coupling, and the performance in general is better. And in our case, our coupling is at the system level. We don't do the peer-wise level. So that's why the scalability, the flexibility, and that will be better and easier for people, because the people only need to develop one interface to connect to the system. Then it connects to everything already connected to the system. I think that's maybe the difference in my understanding. So we have, I think, two systems have their different features. The CSDMS system has a better performance. It supports the tight coupling as well as loose coupling, but it coupled at the peer-wise level. Ours at the system level, so it's only support the loose coupling, not support the peer-to-peer wise tight coupling. However, it will be easy to extend.
I also want to add one point, that is, I think the user base could be different, because for these two systems are complementary to each other, and their goals and objectives are different. For users, like I mentioned, who don't really want to do the pairwise or detailed coupling, ours provide this opportunity for them to spend less time and to make it easier. However, for the people who really want to make a new model or doing the tight coupling and doing the performance detail studies, and the CSDMS does provide that features while ours don't. So I think they are complementing to each other, and they probably serve two different types of purpose or goals. And one user sometimes can want to focus on one aspect of their study, and on the other at another time they may want to focus on the other aspect of the study. And so this could provide them both, and could provide the users who need both.
So this is Scott again. Can I clarify a couple of things? So the way that you guys are understanding CSDMS is not correct. There was a point early in our process where each model that we brought in was treated as something that had to be done in a one-off sort of a way, and that was completely unsustainable. And so we developed a completely different strategy that's very elegant, and it's similar to what you're describing, the benefits you're describing. It's called the basic model interface, and the idea of that system is that. So the idea of that system, and it's described in detail with examples on our website. If you haven't been to our website for a year or so, you wouldn't have seen this, but there's a lot of detail there about how a model developer writes one interface only, that requires no knowledge of our framework, called basic model interface, and that describes your model in a standard way. Then once that's done, we have a harness in our system that slips right on top of it without any additional work by the author. And so I think that the benefits that you're saying this system has are exactly the benefits that we have achieved with our system by the development of this new basic model interface idea. And so I don't see the distinction. I think you're thinking, the way you're describing it in terms of tight and loose coupling and 25 interfaces and all that stuff, that's just completely not right. And I would encourage you to go to our website. There's a paper you can download and read there. There's also hundreds of pages of description of BMI and the CSDMS standard names that go with that. And I don't want to take up any more time right now, but I just want to make you aware that it's not, it has the same benefits that you're describing for your system, but it's much further developed.
So this has been a really great conversation, and hopefully, this inspires some more further conversation offline, but it'd be great if we could now move on to the demo so we still have some time for Alva's presentation as well. So Yao, if you could open up the Adobe Connect application and stop sharing your screen, that'll enable Sue and Daniel to be able to share their screen.
Yes.
Hi, this is Daniel. Can you see my screen now?
And if you could maximize that application, that'd be great because it is a little small. Great.
Okay. This is base trails. What we did was put in components here inside. I'm going to show you first a couple of examples of data, of open data. I'm going to start using this component. This is the retrieve data set. And we have a couple of components to show results. In this case, I'm going to use show plot to show data series, time series. There is a port here called dataset ID. I will connect this to the dataset ID in the show plot component. And now we'll fill the inputs. Let me open them first. Just a user, a project name. I will give a name to this dataset that I'm going to download. Now, the variable name, that is a word key, previously configured in an administration application that is part of this system. Now I will give the coordinates of the point that of the area that I want to test this time.
So is this a search that you're formulating here?
This is David. This basically, Daniel is trying to show you that the open data part of this system. And so basically, if you want to look for some data and retrieve the data, and you provide the area, the coordinates of the coordinates of 4 points, or 2 points actually, and that bound this area, and then the time and period that you are interested in, for example, and then Daniel is showing you how you are using this framework and to get the data.
Which in this case is precipitation inside that specific latitude, longitude box and time interval.
Right, and so and also with that time period. And this is the CUAHSI data source.
So this is coming from the CUAHSI NLDAS web service, is it, or?
Right. This data source is coming from CUAHSI.
Which service in CUAHSI?
What do you mean by which service?
Well, CUAHSI has about 100 web services registered there.
I think he's hitting the catalog. It's a discovery service.
Okay, so we're looking for the keyword precipitation in the catalog within that bounding box.
That's correct.
That's correct. So basically, like Yao said, the CUAHSI, the data discovery part and the data access part are the two agents that we wrote that, Yao student wrote that connect this.
No, but it's not discovery because you got the data itself, so you must have hit a service.
Right, exactly, yeah.
Well,
that I think to say
yeah.
automatically pull the data.
So I think you had, is that one of the Booleans that you filled in to automatically pull the data as well as once you discovered it?
Right. Yeah. Use your search.
If I may just clarify a little bit, what the work that the agent then is doing according to the parameters that are sent to the agent, and he just search for which data sources are available, and then it downloads the data that became available after the search. And there are two separate agents because if you already know all the parameters of the data source that you want to download, then you can also access that data source directly. In this example, then we are searching and at the same time downloading the data.
Okay, so I mean, it's one question. I mean, this gets into weeds, but somewhere are you also then returning which of the sources that you actually hit? Where is this data coming from? Do we know that?
In the result of the search, not directly. With the HIS agent, you can know it after the fact. After the data is downloaded, you can know which data from which data sources you retrieve.
Okay. All right.
Dial in and figure out where he was hitting the whole time.
I will show a second example with stream flow. I'm going to change the dataset name.
And this is also from CUAHSI.
Would there be a way to pick these latitude and longitudes on a map? Because it's kind of hard to think of a box like this.
Are all the time.
It's the demo, guys.
I know.
Are all the time. When do you type it in?
So the answer, of course, is yes. Of course, it's possible, Dave.
Yeah, everything's possible.
And then upgrade straight into a Hydro desktop.
I'm seeing a width there. I'm not seeing a height. Is it assuming a square box, I guess?
Yeah, so it's a square box. And so when we type that in, for example, in the CUAHSI database, and that discovery or the search engine in the CUAHSI HIS part search, what are the data are content in this box. And if it only finds one, and it shows one. If it finds multiple, it shows multiple. So if you want to know, if you want to study an area and then you give a large coordinates to cover a large area, and then all the data and CUAHSI data HIS database has included will show up, and then you can look at each individual of those.
So now it seems not.
Yeah, our connection on the internet is a little bit slow here in this room because we don't have the wired connection. It's a wireless connection,
Okay.
and this is in real time. And we are actually going to the CUAHSI database right now.
I see. Problem.
Hovering and then.
Yeah.
This is the second example, a stream flow from some gauges in some area. If we look for more, we find more gauges in the area, we will retrieve all of them. And now we're going to look another example with another source. This is USGS. This information is stream flow also from another time, other coordinates.
So this is for the USGS database.
I didn't actually see anything from that previous version. Did somebody else, or is my connection just getting lost?
Network connectivity was lost.
Our network connectivity is lost.
Oh dear, okay. So it's not only me.
I don't know. I mean, again, I don't want to really wade into this whole discussion of CSDMS and OHMF, but I really do see this as kind of a different objective, I guess. And so I don't know. I typed something in the box. I think this is really an important discussion to have about what the relative, what the different contributions are of these efforts. I do think, I guess I see them as being having a fairly different objective from one another. One being primarily for just a simple model developer, getting some tools to work in a more modern modeling environment. So anyway, I'm going daily values.
Just a quick comment to that, Rick. This is Scott. What I've learned from being in this game for a few years is that as we all try to get our minds around other people's systems, we tend to create a snapshot in our mind, and we try to create a boundary around it as to what it does and doesn't do, so we can sort of internalize it and compartmentalize it and categorize it. But to really do it right, you have to do a ton of homework to read about other people's systems, and that means ESMF, OMS, OpenMI, this new one. It's a lot of work to really get your mind around what the system actually does and what its objectives are and how it's designed. And that's just something you have to do, and it's documented on our website. If you go to Basic Model Interface, there's a CSDMS Basic Model Interface. If you Google for that, there's a pretty elaborate discussion of what our objectives are and how we designed it and why we designed it that way and all that stuff.
Okay.
We are restarting the system to see if the connection will be better.
Should we move on to Alva's talk, or what?
So why don't we move on, and then maybe we can come back to the demo at the conclusion of Alva's talk, if that's okay.
Yeah. And
so if you could stop sharing your screen in the Adobe Connect application, and then Alva, you should be all set to share yours.
Yeah, let's yeah, we're trying to share off the screen.
Okay, there we go, perfect. So Alva Couch, for those of you who don't know, is the director of the new Water Data Center, and he's going to be talking semantics now in the CUAHSI. So Alva.
Okay, first of all, I apologize to those of you I've talked to before because it's going to have some overlap with the webinar I did before. However, I'm putting some new slides in that should be a little more specific about what I plan. Today I'm going to talk a bit about the plans for SKOS versus HIS Central, what I want to do with it, why I want to do it, and what the architecture will look like. First, what's SKOS? Short for the Simple Knowledge Organization System. In simple terms, it's a mechanism for defining and publishing controlled vocabularies. We're going to do that via endpoints that are ostensibly web pages for all practical purposes. These endpoints have a special and powerful idea. They give us cross-references to other endpoints that might be maintained by other entities. So what is that endpoint? Ostensibly, it's a simple idea. It's a web page. It just so happens it's machine readable. And it defines a single term in a controlled vocabulary. It contains the term, an optional definition, and cross-references to a number of different terms that might be relevant. And it also contains cross-references not just on our vocabulary server, but on other people's vocabulary servers. And that's part of the reason that I think it's really important to implement. Now, the point of SKOS is that it provides a way for a discipline to define its vocabulary. There are several SKOS servers out there that are of interest to me. It provides a way to define cross-references between vocabularies so that we don't have to do the work of making controlled vocabularies that are actually being made in biology, chemistry, physiology, and other disciplines. It also allows us to share the work of creating controlled vocabularies with others. Now, this is a major strategic change in what we're doing here. So far, all of our work in building controlled vocabularies has required us to input every term. We're now going to try to exploit other people's controlled vocabularies, and that requires a major difference in the way we think. Now, how is that going to affect HIS Central? First of all, I'm going to be able to pull in vocabularies outside hydrology and water science. I'm going to be able to expand our control vocabularies based upon the work of others without simply inputting them here and duplicating work. And there's also a very important thread of work out there, which is that people are translating control vocabularies into other languages. We'll be able to do that by cross-reference without translating the vocabularies ourselves. Now, first we have to get a major understanding of the difference between a term and an endpoint. In the current HIS Central, terms are really only known inside the system. We have two components, an editor and a production vocabulary. They're defined by content and numeric ID, and pretty much the meaning is not accessible outside our system. In a SKOS system, terms are publicly available. Other disciplines may refer to our terms, but more importantly, we may refer to theirs. And that gives us a kind of power that we haven't had.
So, Alva, why do you say meaning is not accessible outside of HIS Central? I mean,
so you're going to be able to list the vocabulary terms, but the meaning of a term is its relationship to other things. And so if, in fact, I wish to understand the meaning of something in a global context, in particular, if I wish to cross-reference this term or crosswalk it, as some people like to say, with a GS term, I can't really do that right now.
Okay, so maybe there's not connections, but it seems like the meaning which is given in the description should be there.
Yeah, but
one would hope the descriptions are sufficiently descriptive to actually convey them.
Using our CVs with our ontology. Let's be precise. When you say HIS Central, are we talking the ontology or the CV, which is an ODM thing?
Yeah, when I say HIS Central, I'm referring to the two ontologies inside HIS Central, one of which is the concept ontology, and the other is the relationship between concepts and variables. Both of these right now are sort of maintained externally. We don't actually expose meanings except in the concept editor in his.CUAHSI.org. Right now, we don't really have the definitions online.
So you're not referring to the controlled vocabularies, where for variable names we do have definitions online, for units we do have definitions online, for
yes.
so on. Now those definitions may be too succinct or insufficient and certainly aren't in other languages, but they're there in English at some level.
Yeah, they're there, David, but Alva will talk about some of the changes that, like referring to linked data, that will make those pages more dynamic and more accessible.
Yeah, the mere fact that something is available online doesn't mean it's necessarily available in a form that's reusable. What we're trying to do is to make this reusable and to make it so that tools using the data have access to the definition, among other things. There are a number of changes that I'm making. The fact that the definition is available in some form, it doesn't mean that it's really available in a standard form.
Right, I'm all for getting them into a standard form and getting them better maintained. Yeah.
I'll be much more specific about what I have to do because there's really a set of tasks that are pretty protracted here. The longer-term goals are to enable use of SKOS terms from outside of our control vocabulary. For example, as a dumb example, iodine in the liver of cod refers to 3 disciplinary SKOS taxonomies. There's iodine in a chemical taxonomy, liver in a physiology taxonomy, and cod in a biological species taxonomy. These 3 things, these 3 taxonomies, are actually maintained elsewhere. Right now, we have a fairly incomplete idea of chemical taxonomy, while the chemists have been going past us and building a very complete one. Likewise, in our concept of biology, only the terms for biology that we currently need are in the taxonomy. And so we constantly have to transfer terms from what they know as their taxa to what we know as our taxa. And the net result of this is that we have to enter everything into our system. I'd like to get around that. And longer-term goal is to not maintain control vocabularies for things other people are maintaining control over, especially when there is confluence of purpose, especially when they're trying just as hard as we are to make something clear. Now, when we understand how I'm actually going to deal with this, let's explain the basic concept of linked data. The whole point of linked data refers to the process of including semantic metadata. The whole point of that is that we can then define what our terms are in the reference and in the data metadata. The enabling technology is SKOS, and the basic plan is to support linked data in WaterML 2, which is by embedding SKOS references to metadata terms. What that means is that somebody who gets a WaterML 2 packet will be able to tell exactly what the definition of those terms are from the packet and its references. They'll be able to look that up in a SKOS server and be able to do something with it. Now, in order to enable linked data, we have to understand what we're really trying to do. Currently, metadata contains words that describe data, but in the future, these words become SKOS endpoints. The SKOS endpoint has the word in it, and if we wish, the actual user doesn't have to see the endpoint. They can just see the word. But unlike a word, an endpoint can embody public depictions of meaning, synonyms, and synonyms in other languages, which means that we get closer to the meaning of things. While we can put out the meaning of terms right now in some form in XML, this allows us to have a relatively standard and operable mechanism for broadcasting the meaning of a term. Now, a simple idea of this is the following. If I've got two data sets and I want to link them, right now I use the term nitrogen as a common link. Now, that's a stupid example, but it's just there because I was in a hurry. And in the metadata, there is a term nitrogen, and there are all kinds of weird synonyms for nitrogen. We could even put it in, we could say nitrogen in water. We can say all kinds of weird things for nitrogen, especially if we're not following the ODM. But those two terms, nitrogen, can have one set of synonyms in one system and another set of synonyms in another system. If we go to a linked data system, then data set 1 and 2 are going to refer to some kind of SKOS endpoint. Now, it turns out that it can be even more complex than this because they can actually refer to two different SKOS endpoints that cross-reference with one another. But the linkage is by use of common uniform resource indicators. We've got synonyms we use that are actually going to be coded into the SKOS endpoint. Synonyms proposed by others will be coded in there as well as cross-references, and synonyms in foreign languages as well. So this is more of an information representation thing than an information content thing, which is part of the reason that I believe it's practical to do. Now, what's the importance of this? Before linked data, the concept of a synonym is local. In fact, we can say that we have exhaustive synonyms for our system, but if we tie our systems into the global systems, they might have different synonyms in GEOS. They might have different synonyms in other large data gathering systems. I want to be able to talk with them and understand what their synonyms are. After linked data, once we have a map between our ontologies and everybody else's, synonyms are a global concept with cross-references to other global repositories of synonyms as well. So, what's the real point of this? Users won't see much difference, because in fact, the fact that endpoints are plugged into data is not something that's actually going to be exposed to a user. The client will figure it out and expose the definition. The user might find out that if they mouse over a particular term, now they get the definition, whereas before they didn't. Behind the scenes, however, there are major architectural changes, and here's a preview. Our current control vocabulary workflow has a couple of manual processes. We've got a CV editor at his.quasi.org that builds the CVs, and we've got manual downloads via ODM tools into the working variable CV on a hydroserver. We've also got manual downloads into the working variable CV in HIS Central. The approved mappings between the two concept and variable hierarchies are via HIS Central, and the concept ontology has manual edits. Now, this has an architectural problem. In order to really make it work, I have to change the architecture, and I might as well implement SKOS at the same time. The basic workflow is as follows. We take the CV editor and make it the definitive source for the editable variable CV in the concept ontology. We put the approved mappings process in the CV editor itself, and we communicate its decisions to both HIS Central and to hydroserver instances. In case you're wondering about performance, we cache the SKOS endpoints in HIS Central and hydroserver instances. But if you look at the difference between these two diagrams, you begin to see the major changes that we move the approved mappings from HIS Central to the editor, which is sort of where they belong, and we also make all of the communications between things not manual service downloads, but essentially automatic references. The net result of that is that when you put a new term into the CV editor and approve it, it becomes available to the endpoints, to hydroserver and to HIS Central immediately. There's no delay. The whole point of this is to improve the user experience. And in a second, I'll show you how it improves data publication. Now, just to look into the future, there is a reasonable concept that we should actually be thinking of the concept and variable groups as one ontology through mappings. The whole point of this would be to define a controlled vocabulary editor that does both, and then we have SKOS endpoints that are used by HIS Central and hydroserver. Further, at the bottom of the diagram, we see other SKOS services, including biological taxa, chemical taxa, etc., that are used directly by HIS Central and hydroserver instances through cross-reference. In other words, we are no longer authoritative for other domains. But the good news of that is we don't have to put any more bizarre chemistry terms into our ontology. We're actually going to already have them there because we will get them from the chemistry ontologies.
Do we know that the other SKOS services are going to sort of meet our needs? I mean, the ideal of doing this is great, but I guess I'm worried that they're going to be in slightly different formats that aren't necessarily compatible.
Well, the only question is, are you going to like their naming schemes or not? They are, in fact, concept ontologies. So from the basic level, they're just concepts like we are. If you don't like their spellings, then we'll have to do cross-referencing inside ourselves.
Well, I think they'll have to take their spellings because they're the authorities, but I guess I'm worried about more system compatibility things.
SKOS is, the whole point of SKOS is to get rid of system incompatibility issues.
SKOS makes things work more, the terminologies work more like a thesaurus. You can add stuff, but there's a set of core sets of information that you use and utilize.
Yeah, and you can always put your own spellings of terms in and cross-reference them.
I guess my reaction to this, Dave, is I think that we're going to have to figure out how to map our use cases and come up with sort of best practices, which may require some adaptation of these terms of how we use them. Like right now, for example, we have all those biological species, but we don't have very many use cases of what we're really doing with all those biological species. Are we using this as a variable when we're going to then actually be doing count or density or biomass, or what are we doing with them? And I think until we can, I guess I'm assuming that until we get to the point of these specific use cases, we're not sure how well these services will serve our needs, and I have little doubt that we're going to have to figure out how to adapt them. And I think that's what we've been learning and working with the Shale Network people as we get into more kinds of sample media and more kinds of descriptions of variables. We have to figure out how to organize our information model and our descriptions that are robust against all these different needs. But I think it's difficult to answer the question abstractly.
I mean, I think that's right, and I guess I know a lot of the biological terms came in when Tim Whitaker was working on a biological data model that the guys in Texas were working on. So I guess there are use cases that have driven many of the terms we have.
But one of the nice things about this particular proposal is that we don't have to worry about future use cases.
Right. I really like the idea of having other domains be in charge of their terminologies.
And we can always put in our own terms if we're not comfortable with theirs. But it decreases our maintenance task, and we no longer have to be, quote, embarrassed, unquote, that we don't have a whole chemical taxonomy in our representation, or that we don't have an entire biological taxonomy. Right now, it looks like to the external user that we have a partial ontology. We don't have a full ontology. But, you know, frankly, we can't have a full ontology under the rules we're functioning under. We're just putting in what we need.
Right, yeah.
This allows us to put in everything else in one shot without even working too hard. And then people can reference that as they need to, which means that a whole maintenance problem goes away for an entire subtree of the concept ontology. It just goes away. It just disappears. And provided that the chemists are using our data, then they will like the terms that they are using because they have their own political process for that. The only thing we have to do is define terms that are unique to us. And that fundamentally changes the way that we manage these things. Now, as we go on, okay, let me go back. Okay, I'm going backwards. Okay, now, the problem is that there are certain caveats. SKOS requires some assumptions on how SKOS services operate. There's a maintenance issue, and there is a change in publication procedures. In Netiquette for SKOS, you never get rid of an endpoint. Once you've published an endpoint, somebody can link to it, and you don't know who. So SKOS endpoints should never disappear. They should be deprecated with cross-reference. Once you put something up on SKOS, it shouldn't go away ever, but it can point to a term that's better. Also, publication processes need a lot of work. I'm basically doing this at the same time. Well, when you're setting up a publication system, you set up a server, you register provisional variables, you define the variables on the server, you register the server, you wait for the provisional variable approval and the harvest. Then, if you have any unregistered variables, you register the new variable names and or edit the variable names in hydroserver, and then wait for approval and or harvest, and then tag and map the variables to concepts and publish. I propose several changes in this, most of which are to make the publication process a bit more immediate. Here's what I'd like to do. You set up the server, you define the variable names in the server via SKOS, and if SKOS finds that there's a variable name that it doesn't have that you need, then you register those new variable names in a seamless process. You don't have to do something different to register them. This is part of interacting with publication. You tag provisional variables with concepts when you define them. This is fundamentally different. Notice that now we tag variables to concepts when we discover them via harvesting. We're going to tag them in advance. And we're going to use provisional variable names on the server. Then, harvest is going to be instantaneous. It's a minor change to make it possible to harvest a single network by itself. An instant harvest there leads to that variables are automatically mapped into concepts via SKOS. They are not mapped in HIS Central. They are mapped in the SKOS server. So you begin to see how I'm thinking. And then, if there are any provisional variables left, there's one wait. We have to approve or modify the provisional variables, and if in fact we've approved them or modified them appropriately, then you can publish. So we've cut the system down from 2 waits to 1 wait, really. And the only wait is for the human action. The idea of waiting for a harvest, especially a harvest of the whole system, is not necessary. We're going to make instant harvest instant feedback. That harvest is going to know about the SKOS tables, and it's going to point out anything right there. Anything that's wrong is going to be pointed out at that point. So the differences are simple. Concepts and variables are defined together rather than separately. Harvesting is pretty much instant. It doesn't take but a few minutes to do a harvest. There's no post-harvest tagging step. It's done in the editor before the harvest. You can register provisional variables as part of the same process. In other words, there's not a separate process for going out and trying to get a variable. And you eliminate as many waits as possible. So finally, what does this do? Adding SKOS support allows us to utilize controlled vocabularies described by others, but it also does considerably more. It allows us to capitalize upon internationalization support. It allows us to participate in the Global Linked Data Initiative and become a linked data site, to become one of the cool kids on the block. And it simplifies several aspects of data publication in the same exact way. Well, see, the basic point is that some of the pain points in data publication are simply the controlled vocabulary transport protocol. And so if we have a different transport protocol, we solve the problem in a standardized way. That's it.
Thank you very much, Alva. At this time, I'd like to ask if anyone has any questions for Alva.
Yeah, this question, I didn't get the instant harvest. What did you mean by instant harvest?
Well, right now, the harvester runs asynchronously, and you can call up people and tell them to run it. But right now, it runs asynchronously, and the basic point is that you don't have to run it as a large monolithic process asynchronously. You can actually make smaller harvesting that just looks at a specific site and is very focused. And the whole point of that is that it's a while you wait thing. It's not a thing where you go and come back tomorrow, which is what it is right now.
I guess I have admin privileges on HI Central, so I can trigger my own harvest whenever I want for specific services. I guess that's.
Oh yeah, but that's not a solution. Everybody can do.
Yeah, I think that's why I got confused there. I was getting my own perspective.
A change though would be, I mean, because I enabled it to do on one level, it would be easy enough to do if we wanted to change that. I think the decision originally was just because we weren't sure how much we'd be taxing the server by having harvest happening, you know, randomly through the day, so we wanted to put it in control of an administrator, and that was the only reason. But it
so,
could.
Alva, do you think that all the ODM controlled vocabularies can go into the system?
There's no reason they can't. The only question is, how much can we leverage other controlled vocabularies? I think that we're pretty much stuck dealing with all of the local vocabularies simply because we have our own nuances. We have decided exactly what units we want, and we don't really want any others. And so I don't want to go out and hit somebody else's unit ontology. There are certain nuances of our operation where we're making decisions as to what to put in and what to exclude. I'm not going to override those. The only time when I feel like we really need to go outside is when we have a woefully incomplete sub-ontology for an incomplete use case, where we really don't know how it's going to be used. And then it can be very painful to put a lot of new variables in. And that's exactly what happens in the shell network. We have a whole new use case, somebody comes up with a completely different thing they want to do, and then we have to do a lot of edits and a lot of approvals. And so that kind of thing we can actually get rid of. But I do think that we're going to need a local concept of a number of the controlled vocabularies simply because we have decided for very good reasons to exclude certain things.
So, Alva, can you go back to a few slides where you had a diagram of...
Which? This one?
Yes. So you have other SKOS services.
Mm-hmm.
Do you expect them to have mappings between variables and standard list of concepts? That's the first question. Second,
no, we will have to do the variable concept mapping except in very limited cases where they are trying to do whole taxonomies. Because okay, let me explain a little more detail about the variable issue. Okay, it's very difficult for us to use, let's put it this way, I'll put it a different way. Everybody else is maintaining concept ontologies, they're not maintaining variable ontologies. It would be easy for us to use their concept ontologies, but our concept of a variable, our way of thinking about a variable is somewhat different than theirs. Our way of thinking about concepts is absolutely identical. They don't get as specific as us in terms of what they put into their ontologies. So the concept of a variable does not go away in this system, and the need for variable concept mapping does not go away. What goes away is the need to develop and maintain huge concept ontologies. Now, I don't think that our other local controlled vocabularies go away either because we've made decisions as to what to exclude. and I don't believe at this point that I should override those decisions. However, there is a definite pattern in our concept ontology of empty subtrees for no other reason than we don't have human effort. Does this make sense?
Yeah. Now, when you have conflicts between several SKOS services in this box of 3 SKOS overlapping, is there any resolver or is there any mechanism?
Well, my basic idea is that we'll have to decide what's authoritative and what's override. We'll have to give a priority. However, the bottom line is that our cross-references will determine what's going on there. We will either say that what we're going to talk about as a concept is cross-referenced with them, or we will say that a subtree that we are dealing with is held by a specific SKOS server. Conflict resolution in SKOS is an open problem, and the way that computer science mechanisms for doing conflict resolution work is highly imperfect. And so I see this more as, shall we say, delegating certain subdomains to certain ontology servers, and we'll have to make a strategic choice as to which ontology server is the best one. Conflicts in this case, let's put it this way. We will avoid conflicts by delegating only certain parts of the subtree. And that's the best way I can say it. Because frankly, there's honestly no conceivable conflict with the chemical taxonomy and the whole chemical branch that we have within our measurements. There is conceivable conflict whenever we have an overlap. For example, an ontology built for a discipline that's cross-disciplinary. I don't believe I'm actually going to be subscribing to those SKOS servers. I believe I'm going to be subscribing to the cohesive ones, frankly.
Alva, will this give us an opportunity to bring in things like the CF conventions and UD units that, I guess, Unidata's developed?
Well, of course, we can bring in the units ontology from them. That's
they have SKOS servers that we could use? Do we know?
I don't think they have a SKOS server for UD units, but it's XML, so it could be kind of done that way.
Could be gateway.
Yeah.
Could be gateway.
I guess also another thing that is, Scott Peckham's on the phone. He's been working on the CSDMS variable names, so that's another.
Well, that's one where I really like to cross-link.
Yeah.
However, the way that you deal with the fact that there are 2 different sets of variable names is via leaf equivalences. If we can figure out the commonalities and coherences between the 2 systems, then we can actually search in either system. And if in fact there's a pattern to variable names that you prefer, even if we don't like it, we can still reference it and we can still use it.
Right. This is Scott. I wanted to comment a little bit on that last point that, you know, as I've been trying to get my mind around semantics and ontologies, I think of an ontology as more of a web-like thing with where you have hierarchies and subclassing and superclassing and relationships between terms. And then there's things that are just basically lists of terms, like the CF standard names and our standard names. And it's a lot easier to work with those because assuming you can find an equivalent entry in the other list, it's just a lookup table. So it's not about trying to find out, you know, that in the case of discovery, you might need to know that streams are similar to rivers and creeks and brooks, and you don't really know what the data is going to be called. But in the sense of semantic matching, you have a lot more control, and you're not trying to discover similar things. You're trying to match equivalent things, and so it's a different and somewhat easier problem to do sort of semantic mediation between variables or between models or between data sets, as long as you have some kind of a lingua franca that you can map from and to.
Yeah.
Alva, a couple more things about this diagram. So suppose there's a data set being registered to HI Central via hydroserver along with concept variable mappings. And these concept variable mappings are in conflict with a canonical SKOS server.
Yeah, but that can't be in my system because the canonical SKOS server is authoritative, and when you're putting in the variable mappings, you're actually talking to it.
There is no way to override it, right?
There's no override. But that also means that in the main SKOS server you can put in provisional mappings that are approved later. See, the way I avoid having a problem of conflict and override is that I allow provisional mappings to be placed into the thing and then approved later or modified later. And so the basic idea that you do an override, the way we currently do in HIS Central, goes away. The override actually lives in one place in the Central CV editor, which is more than an editor. It's a repository. And in putting it there, we don't really have a conflict because we have a central. It's distributed, but we have a central authority.
Right.
I'm not telling you how many servers are committed to each one of these things.
Yeah, the issue is if we have to curate and modify some of these mappings later on.
Yeah. See, right now, just to be clear, so everybody else understands this discussion, right now you can put anything you darn well please in as a variable, and then you have to fix it later. And the way that's done is by the hydrotagger application that allows you to tag the random variable that you put in that doesn't have anything to do with the control vocabulary, along with whatever you wish to put into it as a concept. What I have actually done is to change the process so that you cannot simply do that. You simply cannot do that. What you have to do is to interact with the master concept variable ontology in some way or other. You have to enter that tagger mapping there. Since the tag mapping is an invariant of the variable as opposed to a variant of the data set, then you have to either think of a bit different variable name to do that, or you have to do something else that's provisional, but that provisional concept is a matter of record in the central repository. In other words, I know that it's provisional. I can tell. And the net result of that is we can follow up.
So,
now,
Alva, in your model that you just described, you said a person can put any variable name that they wish, which is...
Well, that is in the one that's there right now.
Which is true, but there is in the system right now also a strong encouragement to put a variable name from the variable's controlled vocabulary. And it seems like with that we should also be able to have this mapping from the variable's controlled vocabulary to the concept list. And I agree with you that maintaining them all in a central place and having the person develop those tags at the time they're defining it is a good idea. But I think bringing in the variable name controlled vocabulary would at least provide some nudging and coercion to get more consistency in variable names. So, I mean, while a person may still be able to put whatever name they like, they at least are guided to be consistent.
Yeah, well, see, that's a matter of exposing in real time the variables that closely match what you're thinking about. That's a user interface issue.
Right. So I guess I'm not sure what I guess the concern is there. Those variable name controlled vocabularies are exposed in real time with web services right now.
Well, actually not.
Dave, I'm actually pondering redoing that so they come out of SKOS and maintaining your web services. So. Yeah,
right. I mean, so yeah. So if they can be put into SKOS, that's maybe even better. But they're available in real time right now.
As a bulk download, but not as.
No, yeah, one at a time, I think.
So if I understand this correctly, so the Hydro server will be changing to also be linked with this CV editor all the time and very well restricted with it. But we also have a lot of services in the HIS Central which are not Hydro server. That are basically a hybrid that serve water ML and make data available, but they're not part of the HIS system other than they participate in the catalog. Right.
And it doesn't change how we manage those. We still have to manage them via some form of transducer.
Right, but there's not going to be any control over what the variable names they use.
Well, if we write the transducer, so we could do what we want with control. We can, or we might or might not.
I think that's where we've probably made a mistake in the past, and I think when we're writing transducers, we should use standard names, or if there's a true reason why the name is not standard, but it's a good name, we should put it in the list of standard names.
But another critical point that can't get lost in this discussion, though, is that whatever the original data publisher called that variable still has to get transmitted to the user as it's being done now. So I think that's going to be really important that we don't lose sight of that, because we're always going to be doing some approximation to a name. This is particularly true for the non-ODM services. So I know I was just at NASA earlier this week, and to them, they were getting really concerned about what we were doing until they saw that we were transmitting their name. When they saw that the user was getting what they called the variable, then all their concerns went away.
USGS called us on that.
Right. I think we might want to put a different field. We might want to put the other variable names in a different field, because one of the problems that's led to quite a lot of the inconsistencies is that many publishers overload the variable names with things that shouldn't be there, like, for example, the unit. So you sometimes the USGS.
But SKOS, if it comes out as a SKOS, SKOS, it would just have an alternate label.
Right, but I mean, you'll have a variable name that's coming from the USGS that is discharge cubic feet per second, and the cubic feet per second is part of the name.
Yeah, that's right. But all I'm saying is I think we have to be true to that, transmit that to the end user. Our publishers, I think, would demand that.
Well, we should probably transmit that in maybe a variable code field rather than a variable name field.
It's a different concept than our concept of control vocabulary for a variable. It's a different thing, and we have to treat it separately, I think.
They demanded that the information is transmitted as it appears on their website.
Yeah, so just as we're doing this, I have to recognize that this is what we're using as a mechanism for discovery, but that the original name has to get transmitted. That's all.
Right, yeah. I mean, I think, did Dave Valentine just suggest that the name be labeled, which I like?
It's alt labeled. There's pref labels.
Okay, yeah.
Labels. There's descriptions. In the original, in WaterML1, there's the things for allowing for multiple codes in there that never really been exploited. Anything else? There's alternate ways to do these things. So.
Another question for this picture.
We can have strange languages like the USGS and the EPA as languages. Can we do that?
Another question. So typically, or at least in biology, systems like that support several semantic formats, including SKOS, OWL, RDF, because these type of arrangements come in different flavors. And there are some SKOS to OWL and OWL to SKOS translators. Of course, some of them are very lost, as you can imagine. Do you have a place for them in this picture?
Well, I would say that, to be honest with you, I'm looking for something that has high utility for the current use cases. I don't yet know what the use cases are. I know I can put a transducer from SKOS to OWL. I know that transducers from OWL to SKOS are pretty much impossible. There are theoretical limits involved. And I know that I can move from SKOS to RDF without too much trouble. Right now, I'm not thinking about that as a major push. I'm trying to solve some pretty specific and tangible problems. The fact that the CVs move around through the system via manual operations. The fact that on most of the hydro servers, the control vocabularies are out of date most all the time. That kind of thing, which is a systemic problem that I'm trying to solve for purposes of curation and for the purposes of data quality. As to whether people really want OWL, well, right now, nobody in this community is clamoring for it. In fact, I'm imposing SKOS over people's apathy, mostly because I see it as having high utility in the sense that it solves a curation problem. So I'm looking at this as solving two problems. First of all, there's an immediacy problem, which is systemic to how hydro server is updated right now. And second of all, there's a long-term curation problem for what I might call the long-tailed vocabularies, to be fair. Because right now, I think that, the shell network is coming up with some pretty long-tailed vocabularies. They're coming up with things that they'd like to use where I think it's reasonable that there would be a CV term for what they're trying to do. And I think it's reasonable that we might not have to work too hard.
So this has been another really great and important conversation, but it's about 1:30 here on the East Coast, so I'd like to switch back to Yao and Daniel to get their demo before we take up too much of your afternoon or morning, depending on which coast you are.
Soon it'll even be afternoon on the West Coast.
Okay, here is the result of the USGS example that we were showing. Let me close that one now. It was, for you to remember, we were running another example, retrieving data from USGS. Here are the results. The next example. Here we have 4 data sources. 2 are Turing satellite precipitation algorithm 1, precipitation algorithm 2, evapotranspiration from GLDAS, soil moisture from GLDAS. Let me prepare the output.
So this is the VizTrails engine that you're showing, is it?
This is VizTrails, and MSM run inside VizTrails as a set of a package of components that you can see here in the left side.
So basically, we write our core into VizTrails.
So here you can see 4 rows. Each row is one data source. Each column is a time step. We are seeing then in the first row Turing satellite precipitation algorithm 1, in the second row algorithm 2, in the third row GLDAS evapotranspiration, and in the fourth row soil moisture from GLDAS. You can see here the Great Lakes and Florida. It's a bigger area than the others. I will clean that and show another example. Now we are not only retrieving data, we're also using the MKS algorithm and framework. The MKS will allow the user to retrieve all this data and adapt this information to the model. The user will be able to change scale, change resolution, and fuse different sources of information. In this case, we are going to use the MKS framework just to show one single data source in different resolutions. We are going to retrieve in one resolution in 0.25 degrees, and we are going to show in several resolutions. You can see each of those boxes is going to show the information, and the MKS is able to run only once and give as output all the scales that you need.
So for example, if a modeler wants to collect different data sources, and the different data sources may have, for example, precipitation measured for the same areas, but with different instruments and with different uncertainties associated with the data, and also probably different resolutions. And then the modeler can actually use our data fusion algorithm built into this system to fuse the data at different resolutions, and to use the fused or the original data and the resolution they want.
Well, thank you very much for the demo today, and thank you to Yao for the presentation as well, and Alva for your presentation, and I'd like to thank everyone for attending today's call.
The results are coming out.
Oh, okay, sorry.
Yeah, sorry, because the wireless network here is slow, and so it takes time.
Oh, I'm sorry. I see the blank screen now, so I was thinking it was.
Yeah, because when it takes time, the screen disappears, and here.
It will be 20 seconds. Don't worry.
But then it doesn't show up.
Yeah.
Oh.
It sure didn't crash?
It shows on Daniel's laptop, but not on the bigger screen.
You can see it now.
Oh,
here.
There we go. Perfect.
So this is the one data set retrieved from NASA satellite at different resolution, at one resolution, and it is fused to a different resolution.
I'm sorry, because of the problem with the network, it got a little disorganized. But here you can see the same data source in different resolutions. Let me clean a little bit so it gets organized. Now it's organized. The first row is scale 0, we call it. It's just 4 degrees. It covers all the area that we are covering. The second row is scale 1. It means 2 squares for each side. It will be 2 degrees resolution. The third row is resolution 1 degree, and so on. We call it, for example, the information was retrieved in scale 4. It means 2 to the 4, 16 cells per side, a square box of 16 per 16. Here we see a scale 0, a scale 1, a scale 2, a scale 3, and then we jump to scale 5. We don't show a scale 4, that is the original, but you can see maybe that scales 5 and 6 are the same size. This is because they show the same information. This is because the algorithm cannot create more details than the original 4 scale.
So basically, the original data is at the scale 4, and then if you want scale 5 or 6, which are finer resolution for your model, and then the algorithm can rescale it for you. But then in terms of the information, it cannot be any better than the scale 4.
We are going to see our last
so the last example.
That is the actual fusion that you saw you saw in the slide by Yao. Here we are retrieving information from 2 data sources. The one that you can see in the left side here is GLDAS for NOAA. In the right side, I have GLDAS for BIG. The first one is in scale 4. Sorry, scale 2. The second one, you see the second row, is scale 4. But we want to fuse them and get the result in a different resolution. Let's say in this case, scale 3 is the third row. The third row is the final result, where you see the fusion of the 2 previous rows. And the reason to do that is that any model could need the input in that way. So the AS can be used to change the data.
If a user or modeler wants information from 2 different models, for example, and one model is at a coarser resolution, the other model is at a finer resolution, and the modeler wants to take advantage of both model strengths, and so this user can fuse the data from 2 models at different resolutions to his or her own model resolution, or at the same resolution of the original data. But then the point is that you can do 2 things. One, to take advantages of the strengths of each model and fuse them, and then second, to get to the different resolution.
In this case, we are retrieving information from 2 sources. We are adding noise to both of them and fusing them, just to show that we can use the MKS to improve the information and sort of denoise it. You can see. I want to show the future.
So this, for the sake of the time, this is going to be the last slide in the demo to show. So this is the results. Hello, anyone there?
Yep. So, sorry, does that conclude the demo? Sorry.
Yeah.
So, do we have any more questions for Daniel and Sue and Yao?
I just want to jump in. I think it's really important. I mean, we've been talking here a little bit at San Diego about, the stuff that Scott's brought into CSDMS from ESMF on doing the same kind of regridding. So I think it's really important, though, that Yao and Sue talk with Scott and follow up. And that would be an important outcome of this call.
Yeah, something very important here is that this model or sources that we touch here, for example, if you want to connect this to a model, you will never change that model at all. The developer of the model do not need to add anything to this, just write the agent that is out of the model. And this little slide shows a little bit of what we plan it to be, just like retrieving data sets, preprocessing data with MKS, and then using the agents to connect the models and have the coupling. And that's it. Thank you very much.
Yeah.
Thanks.
Yeah, thank you, and thanks everyone. Thanks Rick for the great suggestions, and actually Yao and Scott has already said that they will discuss in details, and we will in close contact with, and discussing with Scott, and then thanks to Rick, the very good suggestion as well. And we want to thank everyone, and if you have any questions, comments, and suggestions, please feel free to contact Yao and me and Daniel and Miguel. And we welcome all the comments and suggestions to make our system better. Thank you.
Just for everybody on the upper right corner of your chat box, if you have the ability of emailing yourself the chat history, if you want to capture those references Scott gave, just for your info. Okay, thanks.
Thank you, everybody.
Thank you, everyone.
Where's the option?